These are the video notes that's going to go along with geometric patterns and direct variations. So our question of the day is, can I translate a direct variation geometric pattern? So what's going to happen is they're going to give you a pattern of pictures or shapes or just different items, and they're going to tell you what they want your input and output to be, and you're going to have to, one, create a table of values, create a graph, and then create the equation to go with it. Okay, so if I look at example 1 right here, I see some ampersands. Okay, my @ signs. Now, let's look right here. We're going to let X equal the number of columns in my picture and Y be the total number of @ signs. Okay? Now, when I'm collecting my data, because this is a direct variation, the first point I don't see, which is 0, 0. Okay? Well, if there's no columns and no @ signs, there's nothing to see. Okay? Now, if I look at my first figure right here, I notice it has 1 column, and in that 1 column, there are 2 @ signs. Now, in my next stop figure in the pattern, I notice it has 2 columns for a total of 4 @ signs. So if you think about what's happening, you're adding a column each time, but every time you add a column, you're adding 2 more @ signs. Okay, so right here, I have what? 1, 2, 3 columns and a total of 6. Okay, so now I've just created the table of values that go with that pattern. Well, let's just very quickly do the easy one right here. What's the equation? What am I multiplying X by to get Y? Well, that's easy. It's doubling. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So M here is going to be 2, and that means Y is equal to 2X. Okay? Now, let's go ahead and graph this. So let's see. We're going to graph 0, 0. We're going to graph 1, 2, 2, 4, 3, 6, right there. Just get my paper so I can draw my line. Now, I'm going to just make a really close point right here about my arrows. I am not going to put an arrow at 0, 0. I'm only going to put an endpoint. Because what happens is if I go below the 0, 0, I'm down here in negative numbers. Well, how in the world can I have a negative amount of columns and a negative amount of @ signs? I can't. So it's not possible. 0, 0 is as low as you can go. That's your minimum. But I can keep adding to my pattern, so I can put an arrow at the top because it can go on forever and ever. Okay, it doesn't have to stop going in the other direction. Okay? Now, pause and copy if you need to. Now, number 2, again, is a pattern. Looks different, but it's still a pattern. Okay? Now, let's look at example 2. We got triangles right here. Notice my figure. 1 triangle, 2 triangles, 3 triangles, 4 triangles. Okay? The problem says we're going to let X be the number of triangles and Y be the perimeter. Now, there is something here that we have to know is implied. Okay? What we know that's implied is the side of a triangle is 1 unit long. If it does not tell you a specific length for the side of those triangles, we know they're 1 unit long. Okay, just like if you have X, we know that's 1X. If it's not 1x, they'll tell you like 2x or 4x, okay? 1 is understood, okay? Now, let's talk about a table of values. Again, this is a direct variation. So what's the first point that I'm going to put in my table that I don't see in the pattern? Well, 0, 0, right? No triangles, no perimeter. Now look right here, my first figure, I have 1 triangle. The perimeter here is 3 because we know to find perimeter, we add the length of the sides up, so it's 1 plus 1 plus 1, which is 3. Now, my second figure in my pattern right here has 2 triangles, right? So there's 2 triangles. What is my perimeter? There's 1, 1, 1, 1, 1, and 1. So 1, 2, 3, 4, 5, 6 units. Okay. Now, I bet you can already see the pattern and you know what's coming next. I have how many triangles here? 3. What's my perimeter? Well, each triangle has a perimeter of 3. So there's 3, 6, 9. Okay. What is the equation for this? Oh, that's easy too. M is going to be what? 3. So y equals 3x. Multiplying by 3 each time. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. Now, let's graph right here. So we're going to have 0, 0. We're going to have 1, 3. We're going to have 2, 6. And we're going to have 3, 9 right here. Okay. I'm going to connect them. Again, let me ask you about the arrow. Arrow at the top. Do I have an arrow at the bottom? Because I can't have a negative number of triangles, and I definitely cannot have a negative perimeter. So this has to stop. Let's do a very good job drawing it. Has to stop right there with an endpoint at 0, 0. Okay. So pause and copy, and we'll go to the last one. Now, number 3. I want y'all to think about them square pizzas they used to serve us in the cafeteria. Okay? We're going to let X be the number of interior line segments or slices, cut throughs, and Y is the number of slices. Okay? So X is the number of like cuts or interior line segments. Y is the number of slices. So the first one we don't see, we know is what? 0, 0, right? Okay. Now, look at my right here. I have 1 cut or 1 interior line segment. How many slices does it give me? It gives me 1, 2. So 1 segment, 2 slices. Now, this one over here, be very careful. It's only got 2. It's got this one right here horizontally, and then it's got 1 going vertical. Okay, it's not 4 different line segments, it's 2 long ones crossing each other. So I have 2 line segments, but how many slices did I make? 1, 2, 3, 4. Okay, if you look here, I've got this vertical slice on this third one. And I got this diagonal and that diagonal right there. So I have 3 interior line segments. And how many slices did I get? 1, 2, 3, 4, 5, 6. Okay, so what's my equation right here? What is my M? What am I multiplying by? I'm multiplying by 2, aren't I? They're doubling. So it's going to be Y equals 2x for my equation, right? Make that look more like a Y. There we go. Now, can we graph this? Oh yeah, we can graph this really easy. So 0, 0, 1, 2. And did you notice that the equation, the table, the graph, the equation for the first one and the third one were exactly the same? So the same table, the same graph, and the same equation represented two very different patterns, didn't it? Okay, again, I'm going to stop at 0, 0 with my endpoint. Okay, because I can't have negative numbers of slices, and I can't have negative number of cuts or interior line segments. Not feasible. Okay, now once you get these copied, make sure they're in your interactive notebook and work on your assignment for this on Canvas.